Assalamu alaikum. Today we're going to start with chapter 10, Vectors and the Geometry of Space, 10.1 and 10.2. First of all, we have vectors in the plane and in space, three-dimensional space. A point in three-dimensional space, Euclidean space, R cube, is specified as an order triple ABC. So ABC, it is represent the distance from the origin along of the three coordinates axes x, y, and z. For example, we have point here. So here we have point 3, -2, and 4. Okay. So 3, -2, and 4 that represent x and y and z. Here we have so remark in R square the coordinate axis only x and y is specified like x and y. For example, if we have 2 and 3, so it is x and y. So this is, we call it R cube. This is R square. 2 axes, here 3 axes, or 3 dimension. We have scalar multiplication. If we multiply a vector y by a scalar 0, the resulting vector will have the same direction as u, but will have the magnitude. Next, on the other hand, multiplying a vector y by a scalar will result in a vector with opposite direction. For example, if we have here u, okay, have u, which is, for example, if we have 2, so 2u, and we have v, or another u, you call it 2, anyone, we have half u. So it will be like we have half u here, and 2, it will be one, this is 1 and 2, it will be like this. So this is 2u. Here here we have vectors in the plane. If we have u and -2u, here negative, so here it will be like u here, and it will be 2u but in the opposite direction, which is here, so 2u negative. Or for example, if we have u and half u, so it will be here, this is half u. Next, a vector with its initial point located at the origin is called vector, a position vector. Next, the vector in the plane and in the space. The position vector A with an initial point at the origin 0 0, and terminal point A1 A2 A3 at the point is denoted by A1 A2 and A3 are the component of A. So for example, if we have here A, we have A1 A2 A3, so it's like the component of A, which is x1, y1 and z1. And so A1 is first component, A2 second component, and A3 third component. And if we want to find the magnitude of the position vector A, so we'll find it as A vector. It will be A1 square plus A2 square plus A3 square. And always if we have a negative result, so it will be in positive because it is the magnitude, it's like the absolute value of the result, so it will be always positive. Remark, in R square we have two components, A1 and A2, and if we want to find the magnitude of it, it will be square root of A1. Here if we want to find the magnitude of A2 and A1, it will be same thing, but we have two components only. Okay, here we have table, vector in the plane and vector in the space. In the plane we have two dimension only, which is x and y. We have A1 and A2. For example, if we have B, it is also the same thing, B1, B2. And if only their components are equal, for example, A1 equal B1 and A2 equal B2, the zero vector is defined to be 0. It is the only vector with 0 length. For example, if we have 0, zero vector, it is 0 0. We define the additive inverse of a vector A to be, if we have a negative, so he call it additive inverse, which is a negative vector A, so it will be negative A1 and negative A2. This say that the vector negative A is a vector with the opposite direction as negative A and same length. So it is like we have A, so it is the same thing if we have negative A. And if we want to find the magnitude of each of them, it will be the same result because the magnitude will be in positive. Vector in the plane and in space. Two vectors having the same or opposite direction are called parallel. So for example, if we have vector A here, so here vector A, and if you have vector B, so if they are having the same direction or opposite direction, for example, like this, for example here, this one, here A and here B, so they are called parallel. parallel. So parallel, it is when vector A and vector B are parallel or having the same or opposite direction. Yeah, so here note the zero vector is considered parallel to every vector. Example, determine whether the given pair of vectors is parallel. So first we have to know how to know if the two vectors are parallel to each other. Let's take example A. If we have A here and we have 2, 3, and we have B 4 and 5. So to know if they are parallel or not, here you can divide 4 over 2. So it is like divide the x component with x component and and y component with y component. So if you start with B, you have to start with B. I mean, if you start with B for the x, you have to start also from B for the y-axis. So 4 over 2, which is 2, and we see for the y-axis for 5 over 3. It is not the same result. So 2 not equal 5 over 3. So it is not parallel. Here example, if we have 2 and 3, and for B we have negative 4, negative 6. Negative 4 over 2, it will be negative 2, and negative 6 over 3, it will be negative 2 also. So negative 2 equal negative 2, that means it is parallel. Yeah, so it is the same thing, are not parallel. For example 1 and example 2, it is parallel. Yeah. Vector in the plane, the position vector A with the terminal point A1, A2, A3 and the initial point at the origin is denoted by A1 and A2 and A3. Here let's say this point, the vector with initial point at B, A1, A2, A3 and terminal point at Q, B1, B2, B3 corresponds to the position vector. So if we have here like vector B, we have so if we have vector B, we have A1 and A2 and A3, and we have Q, we have B1, B2 and B3. So we can find the so the B and Q corresponds to the position vector, which is BQ. It is like Q minus P, which is B1, which is B1 minus A1, A1 and B2 minus A2 and B3 minus A3, and B ends up with this formula. It will be B1, A1, B2, A2 and B3, A3 with this. So we call BQ is a vector. Also for any 2 point A, X, Y and B, X2, Y2, the vector AB corresponds to the position vector X2 minus X1 and Y2 minus Y1. So for example, if we have A2, 2 3 and b 3 negative 1. So we have AB, which is, so let's say x1 y1 x2 y2, so it will be x2 minus x1 and y2 minus y1. So it will be three minus 2, negative 1 minus 3. So it will be 1 negative 4. And also if you want to find the distance formula for the point in, yeah, same thing. If you want to find the a distance for this AB, so it will be square root of x2 minus x1 square plus y2 minus y1 square. This is for the distance. Yeah, so this is for the distance and in 2 dimension, and if you have 3 dimension, it will be the same thing, but we will have z axis. So it will be yeah. For example, if we have 1 negative 3 5 and second point 5 2 negative 3, if you want to find the distance, we can call it x1 y1 z1 x2 y2 z2. So it will be 5 minus 1 square plus 2 minus 3 negative 3 square plus negative 3 minus 5 square, and we end up with 4 square plus 5 square plus negative 8 square. It will be square root of 105. And we can find this is same thing. So for example 1, it will be 0 negative 3 negative 1 3 6 8. We want to find the distance. It will be root 3 minus 0 square plus 6 minus negative 3 square plus 8 minus negative 1 square. And for example 2 or question 2, it will be 2 minus 5 square plus negative 3 minus 4 square plus 6 minus 7 square. And for question 3, it will be 2 minus negative 1 and 2 minus negative 1 also, and 1 minus negative 1 square. Here we have this table. Here if we have this 3 dimension and this is 2D, so it's 3D and 2D. Here A plus B, yes, we have A plus B, it will be A1 A2 plus B1 B2. It will be like A1 plus B1 and a2 plus b2. This is for a plus b. If we have a minus b, it will be a or b, yeah, a1 b1 a2 minus b2. And for scalar multiplication, so this is subtraction and addition, and for scalar multiplication, it will be, for example, c multiplied by vector a, so it will be c a1 a2, and it will be c a1 c a2. Yeah, and if we have the magnitude, it will be c, the magnitude, exact magnitude of c times magnitude of a. Yeah, and so here you have example. You have example, let u 2 minus 1 5 and v 4 3 1 and w negative 6 2 0, and find x if x equal to, yeah, so if we have, this is the point, we have u, v and w, and he want from us to find x, and x, it is tu, which is t multiplied by vector u minus vector v plus 3 multiplied by vector w. So yeah, so let us analyze this. So it will be 2u 2 multiplied by vector u, which is 2 plus 1 5, it will be 4 negative 2 10. And v, vector v plus 3w, it will be vector v, which is 4 3 1 plus 3 multiplied by vector w, which is negative 6 2 0. So we end up with 4 plus 2 10, which is tu, so this is tu minus negative 14 9 1, which is v plus 3w, and we end up with 18 negative 11 9. And also the same thing for a question 2, and same thing for question 3. Exercise compute negative a and negative 2a. Yeah, so basically here you have a and you have b. 2a, okay, I will solve for question 1. Negative 2a, it will be negative 2 for vector a, which is 2 negative 4 1, so it will be negative 4 8 negative 2 plus 5b. So I will solve it here. Negative 2, 2 and 1. So this is for 2a. So it will be negative 4, 8, negative 2. And for 5b, it will be 5, negative 4, 1 and 4. So it will be 5, or I'm sorry, negative 20, 5 and 20. And then we compute the magnitude of it, which is, so it will be negative 4, 8, negative 2 plus negative 20, 5, 20. After we, so negative 4 plus negative 20, it will be negative 14, 24, 8 plus 5, 13, and negative 2 plus it will be 18. And then magnitude, which is square root of negative 24 square plus 30 square plus 18 square.